Welcome back to Mattermosaic, where we break down the science that shapes our everyday lives. If you were curious about how the invisible rules of the universe connect to the world around you, you're in the right place. Imagine looking around right now. The screen you're watching this on, the light bouncing off the walls, even your own heartbeat. All of it runs on rules that are far stranger than anything in science fiction. These rules belong to quantum physics, the study of the universe at its smallest scale. When scientists first started peering into the quantum world, what they found didn't make sense at all. Atoms, which we thought of as little solid balls, turned out to be mostly empty space. Electrons don't orbit neatly like planets. Instead, they hover in strange clouds, existing everywhere and nowhere until we look. And light? Sometimes it behaves like a wave, other times like a particle. In one famous experiment, it even seemed to interfere with itself, as if it could be in two places at once. This world gets weirder. There is something called superposition, where a particle can be in multiple states at the same time. Then there's entanglement, where two particles become linked so deeply that if you change one, the other responds instantly, no matter how far apart they are. Einstein himself called it spooky action at a distance. And then, perhaps strangest of all, is tunneling. Imagine rolling a ball at a wall, and instead of bouncing back, it just appears on the other side. That's what particles do in the quantum realm. It is tempting to think this is just abstract theory, but here's the thing. Without these bizarre rules, modern life wouldn't exist. Every time you use a smartphone or a computer, you're relying on transistors, tiny quantum devices that only work because electrons can tunnel. Lasers, the things behind supermarket scanners, eye surgery, and even your favorite concert light show, are pure quantum technology. GPS, the tool that helps you find a coffee shop or track a delivery, depends on atomic clocks, which tick with incredible precision thanks to quantum mechanics. And if you've ever had an MRI scan in a hospital, that machine is reading the quantum spin of atoms inside your body. In other words, you don't just live in a quantum world, you depend on it. And the story doesn't end here. The future is going to take these strange rules and push them even further. Scientists are building quantum computers, machines that don't just process ones and zeros, but can hold multiple states at once. These computers could one day solve problems that are impossible for even today's fastest supercomputers. There's also the idea of a quantum internet, a network built on entanglement, where messages are so secure they can't be hacked. And in the world of energy, quantum breakthroughs are paving the way for better solar panels, batteries that last longer, and superconductors that could change how we power our cities. But perhaps the most mind-bending part of all this is what quantum physics says about reality itself. Does the universe exist before we observe it? Are there countless parallel worlds where every possible outcome plays out? Quantum mechanics doesn't just shape our technology, it challenges our very idea of what's real. So next time you pick up your phone, send a message, or simply look up at the night sky, remember this. The strange and beautiful rules of quantum physics are at play in every moment. This is Mattermosaic, connecting science to the stories that shape our lives. If quantum physics has blown your mind today, let me know in the comments. What fascinates you most? Superposition, entanglement, or the idea of infinite universes? Don't forget to subscribe for more deep dives into the mysteries of the cosmos. Until next time, keep exploring.